Hi guys, and welcome again to our Cairo Bootcamp, right? So this is the fifth session, right? And in the week 4 class done by Elial, he went through Starknet development tools and framework, which he also gave overview of SCARB, Starknet CLI, and also gave a very deep dive into like different tools on Starknet. And he also gave an assignment. So I just hope that everyone has been doing the assignment and also like try to cover from week 1 to like the current week we are in right now, because it would um, assist us to actually like know who are active in the whole session and the whole like bootcamp that we are organizing, right? So, and today we will have Mulili, who is from like Kenya. He's going to give us a very good deep dive into Advanced Starknet Contract Development. And yeah, I guess this is the floor is yours, Mulili.
Awesome. Thank you, Emmanuel. I think let me continue with the presentation. Let me present my window. Cool. Let me get to the slides. And I say open. Give him a minute. Then add this thing. Cool. Awesome. So can everyone see the slides? Maybe I should. Okay. Yeah, maybe I should keep that thing there. View slideshow. Okay, awesome. Let's get this show on the road. Where do I put this thing so that it doesn't distract me? Let me put it in another screen there. And I think we're good to go. Cool. So yeah, today we'll be talking about building advanced Starknet programs. In the other few sessions, I think you had introductions on how to, you had the basic introduction about Starknet contracts, how to go about building them, what they entail, everything, from the toolkits to the syntax to the semantics, I guess. So today we'll be taking it a bit further and actually building, a workable project that showcases how you can have different parts. I don't want to use the word components here, but parts of contracts working together to make work easier for you and to make like your development experience much more smoother. So let's continue. That's me, Mulili, Starknet Maximalist. That's my Twitter. You can reach out anytime in case you have any questions. You can also reach out to me on TG. I'm always there 24/7, more or less. Yeah. So today, this is the agenda. We are going to learn what components are, the properties of components, and then deep, try to define what Cairo components are. Talk about composability in Cairo and in Starknet smart contracts. Do a bit of syntax deep dive. Try to show what exactly the components and the composability part, how both of them act together to make you, or rather to empower you to be able to create very robust and versatile smart contracts in Cairo. So we'll do some bit of syntax deep dive and components. And then after that, we'll get into the building session where we'll actually build a token sale contract. This will be an automated market maker. If you're not familiar with that, that is like Uniswap on Ethereum, where you're able to swap one token for another automatically without going through an OTC desk. I'll do a conclusion and then I will leave in 5 minutes. Yeah. Cool. So let us define components. Like generally, what does the word components or what do components entail? Like what does the word mean? And that's basically the definition of components. According to the Cambridge Online Dictionary, the word component is a noun, which means a part that combines many other parts to form something bigger, you know? And I think this is pretty explanatory because from this we can infer that anything and everything that we see in nature is basically a composition of components. So nature by itself, the way nature works, it has components, and these components are composed in a particular manner to form something. You have components for cars, you have components for trees, you have components for the human body, like your body has like a million, not even a million, it has trillions of cells that are working together to keep you alive. And all those cells have to work together at all times to keep you alive. If there's an issue, it can lead to serious consequences. And something that is more practical that we have, more or less interacted with is vehicles. A vehicle is not just one big hunk of metal that moves you from point A to point B. No, a vehicle is actually a composition of thousands or even billions of components that have been combined together to make that car, that thing that you see there. And those components, again, they work together. And in doing so, you have now the vehicle that is able to move you from one point to another. So essentially, components are everywhere in nature. They're unavoidable. And it is good to learn from the wisdom of nature in smart contract development, so to speak, so that you can make our life easier and make our work easier. Awesome. So now that you've defined what components are, we can talk more about the properties of components. And components, of course, depending on the component that we're talking about, it can have very specific characteristics about itself. Like, let's say talking about vehicles, a car headlight can have, a very specific characteristics about the intensity of the light, the bulb that is going to be used. But generally speaking, components have at least 4 properties. All components that you'll encounter everywhere in nature or in programming or whatever situation, they usually have these 3 cross-cutting properties or characteristics. Number 1 is that they should be reusable. That means if I have a component, let's say a car battery, I can be able to remove it from my car and take it to another car, and it should work the same way without me having to do some crazy things for it to work. It should be reusable. It should be interoperable. By that, this means that components should be able to talk or communicate with each other. For example, again, going back to the example of a car has a lot of components, one of them being a steering wheel. The steering wheel by itself cannot drive you from point A to point B. But the steering wheel, when it talks to the wheels, so to speak, through other components, it can be able to drive you from point A to point B. And then another, universal property of components is that they should be simple. By this, I mean that components should have a very specific task or function, and they should be good at that task or function. Again, going back to the example of a car should be, when you have a car that is moving you from point A to point B, the wheels should be able to literally rotate. Like, you cannot have a car that has triangular wheels, so to speak. That is not simple. That is not an optimal design. The wheels have to be round so that they can move you from point A to point B efficiently without any issues. And then, of course, components must cooperate with other components. This can is more or less interchangeable with the interoperability aspect of components, meaning that components now, when they work together, they form a larger whole that is able to carry out a specific task. And then again, like it says there, in short, components must behave like Lego blocks. Have that mental picture moving forward. Yeah, so when we talk about components, even in Starknet, even in Cairo, even in other programming languages, so to speak, these are the major characteristics, or these are the overarching characteristics or properties that those components will have. And then, of course, a small splitter there that there is CPU architecture. If you've been in crypto long enough, you might have encountered such a term. It is also based on the above properties. They have tried to make the CPU modular, have a lot of components that do specific tasks, etc. Cool. So now that you've defined components, let us talk about Cairo components. And so just give me a minute. I need to adjust my lighting. Okay, so let us continue. We can now talk more about Cairo components, and from the definition that you have in the official docs, they are modular add-ons that encapsulate reusable logic, storage, and events that can be incorporated into multiple contracts. That is that is a mouthful, that is word salad, but it basically means that components should be able to be reused. Like if we develop a component that does addition, we should be able to reuse that logic and the storage variables in that components and events also in multiple contracts. And of course, components will have the risk properties that we've just discussed, these properties. Cairo components will have these risk properties. And then another key thing to note is that Cairo components are similar to contracts, but unlike contracts, you can never, or rather you cannot deploy a contract by its own. For example, the ERC20 component that has been developed by OpenZeppelin, it more or less has that logic for implementing an ERC20 token, but it cannot be deployed as a contract on its own. It needs to be imported and reused in a contract for that functionality to be available. We will do this later in the coding session. And of course, just to give out a shout out to another one of our tutors called CS Swedy. He has written an excellent article about this. I'll link it below. When I share these slides, you should be able to have a link to that article that explains components, how they relate to abstract contracts in Solidity. Cool. So moving forward, now we discuss about composability. And again, this simply means, like I've expounded on before, when you have one component, you should be able to stack or layer it on top of another component to achieve a certain functionality in a contract. Like in the coding session that we're going to have, we are going to combine the ERC20 and the reentrancy guard components to create a simple token or simple MMM, and with the end goal of showing how components can make programming so much easier, even for complex functionality like an AMM. When you think about it, all the functions that are, that's all the things that take place in an AMM are you have like a wide array of functions that enable the whole thing to work together, and that cannot be achieved easily without the use of components. And of course, we'll see how, when you use components, how they help make your smart contract code much more secure. Cool. Up to there, do you have any questions before I go into the syntax deep dive? Let me check on the charts. Awesome. It seems that we don't have any messages. Cool. Thank you, Katrikaze. I think we can continue. So let's dive a bit deeper into the syntax of components. Before you develop any components in Cairo, there are a few key things to note about the syntax. Number one, each component, you define each component in its own module denoted by the Starknet component attribute. This is very important. Without this, the compiler cannot know that what you're trying to achieve or what you're trying to build is a component. Number two, you define the component interface, and this will contain the function signatures that allow external access to the component logic. I'm sure in the previous sessions, you may have encountered interfaces. Interfaces allow you to more or less define the logic that you expect in the smart contract. The same is expected for the components. You need to have interfaces that have specific function signatures. And these signatures are what is going to allow external access to the component. By that I mean these are the functions that are basically going to be called for that component, you know, by other smart contracts when the contract is executing in the VM. And then, of course, when you want to implement the external logic, it must be done in an IMPL block marked with that attribute, where name is the name that we'll be using in the contract to refer to the component. Like, for example, this ERC20 implementation, you can see they have chosen, we'll see this, match, we'll do a match when coding, we'll see this much more visibly. But as you can see from this screenshot, they have chosen to call it ERC20 EMPL. So anywhere you want to have external logic in the component, it must be inside this block, and you need to have this attribute called embeddable as name, where the name again is the name that we'll be using in the contract to refer to the component. And then, of course, we also need components can have internal logic, logic that cannot be accessed externally by other smart contracts. And then we do this by omitting rather that attribute. Sorry, that should not be block. By omitting the embeddable as name, where again name will be, like we said here, name is going to be the name we'll be using the contract to refer to the component. We omit this, but we can have other attributes, i.e. generate rate. Again, this is from the ERC20 components. We'll see this much when we go much deeper into the code. And that's it. The syntax deep dive, I think I've pretty much covered all that entails the syntax of components. Cool. So let us talk about what we'll be building for the next 1 hour or so, which will be the token cell contract. What we'll implement will be a very simple contract that does the following. It implements the Uniswap V2 style X times Y equals K constant products automated market maker. Again, if you have interacted with Uniswap, you should have come across this functionality where you are able to swap one token for another seamlessly. And then for that functionality to happen well, we will integrate the ERC20 component. I think I mentioned this earlier in the presentation, as I was starting the presentation. And this will allow a user to transfer a token A to the AMM swap that token for token B, and then send the token B back to the user. We'll also implement the reentry guard to ensure that the swap function is locked and the user can't call it again in the middle of a swap. This is necessary so that you ensure that the reserves of that that AMM are not drained. And then, of course, now for the assignment, we will leave room for the contract to be further extended with other components for additional functionality. I.e., if you want to, let's say for whatever reason, the owner of that pool decides they want to pause the swapping, for the assignment, you guys should be able to do that. And awesome. Yeah, again, this explains the Uniswap V2 token sales, how they happen. They happen by a bonding curve. A bonding curve is basically, a quadratic function that ensures that the token price gets cheaper as the supply of that specific token increases, and then it gets expensive as the demand for that token increases. You can see that in this graph, where you have, let's say you're selling token 1 for token 0. If you're selling token 1 for token 0, that means you're swapping in token 0. So token 0 will be, because you're increasing the supply, the price of token 0 at that moment of the swap will be much cheaper, but the price of token 1 will be a bit more expensive as you continue swapping token 0 or rather selling token 1 for token 0. Token 1 will continue getting more and more expensive. As you can see, this hyperbola curve, so to speak, it doesn't touch the X or Y axis. It continues upwards, or vertically and horizontally. Continues this way towards the Y axis and the X axis infinitely. It doesn't touch them unless, of course, we're dealing with Uniswap V3, but that is not the point of this presentation. So if you are selling a token for token 1 for token 0, the more you continue selling token 1, the more expensive the more cheap it will get, because the supply of token 1 will continue increasing in that pool, but token 0 will continue being taken out. And the inverse is true. If you are selling token 0 for token 1, the more you increase the supply, token 0 will become cheaper at the time of that swap, but token 1 will become more expensive. Again, we will see this much more clearer when we go into the codes. And yeah, I think when you start writing the code, all this will become a bit clearer. Cool. And for my presentation, that's more or less it. I think we can get into the codes. Any questions, Hakuna? Okay, awesome. So let me set up my VS Code, and then we can continue. Actually, let me awesome. So we can start a new. Give us. Let me go here. So let me make the directory that we'll be using, and then I open it from the desktop. So again, you can see this is an empty project. There's nothing in it. I'm sharing the correct screen. Oh, sorry. This thing is a bit confusing. Yeah. I think we can now see the project, right? Let me expand the chat here. Awesome, thank you, country cousin. Want to see, make sure I see any messages that are coming in. And then I think I see my Discord. Let me go back to my Discord. Awesome, I think for now this should more or less work. So what you're going to be doing for the next 1 hour or so, let me organize things on my desktop. Things are all over. This should be up here. My screen. Make everything more presentable. Cool. What you're going to be doing for the next 1 hour or so is to more or less implement a Uniswap V2 style contract in Cairo. And we'll be doing it from scratch so that I explain everything about components and composability from scratch. It's going to be a bit taxing. If I'm moving a bit too fast, please tell me. But I'm hoping at the end of this session, you should be able to explain, rather you should have like a very firm grasp of what components and composability, what they entail in Uniswap V3. So to get started, I'll initialize a new project with Scab. I think as from the previous tutorials, you guys have been shown how to do this, like how to initialize a new project. But let me just walk you through it, just in case it's not so clear to everyone else. Where is it? So I will not go through the installation process. I'm assuming that you have Scab and SNForge, installed locally. I will not go through that. I will just go through the process of initializing or generating a new project using Scab, using the CLI. So I'll go into my bootcamp folder, paste the Scab command, and actually maybe the old folder that was there. And that's not there. This V2, and then Scab new uni dash V2. The runner that you're going to use, okay, let me call it that. The runner that you're going to use is Starknet Foundry. Again, I'm assuming this is, you guys have this set up. You get a few minutes for it to install, and then we should continue. As that is doing that, I'll open my VS Code and actually open that folder. Awesome. So we have a basic test contract here from Cairo. And then we make sure that I see Starknet Africa has raised the hand. Yeah, sure. Go ahead.
Yeah, could you please increase your fonts?
Okay. Is that visible enough? Paul, is that legible, or should I increase it further?
That's okay.
Awesome. Let me look. Oh, sorry, I didn't see your chat, country cousin. Sorry. Okay, I think we're good to go. So Give it a few minutes. As that is doing that, let me set up also. I think it's finishing up. Cool. As this is doing this, let me set up or rather, let me open the Open Zeppelin repo that you're going to be using, so that I just copy and paste the contracts. I don't want to install the packages directly because I think that will add a bit more complexity. I just want to copy and paste for now, so that later when you're doing the assignment, you can just come and see, retrace the steps that to implement the assignment itself. So as this is doing this, give me a sec to open the repo. I'll mute myself as I work on that. So checking back on the page, it's still fetching. Give it a few more minutes. Okay, this is fetching. I think I can go ahead and create the module starting on it. For now, we'll need a folder for the tab, which is basically now the Uniswap v2 and then another folder for the ERC20 component, and then another folder for what is it called, the re-entrancy guard. Entrancy guard. And then I'll add another folder for the assignment for the causable. For this one, I'll create an empty file, ERC20, that is going to have the component eventually. And then I'll also create another file for the interface, because again, like we said, each component needs to have an interface. Same thing for the pair. And then the interface for the pair. For the possible functionality or for the possible component, that I will not include, so I'll just add an empty kit file, so that when I push, you guys can clone the repo and then add the functionality there. For the entrancy guard, I'll add the component itself. The entrancy, how do you write? The entrancy underscore guard triangle. And there's thing is still fetching. Is that is still fetching? We can continue and add more modules for the pair for the ERC20. We should also add another folder for the factory, but I think that will be increasing the complexity for this session. So I'll leave that one out. But you guys can extend it. You know, if you want to learn more about ERC20, you can extend that functionality. Cool. So let me close this. Remain with the test for now. And then I'll add more modules for the pair. Of course, the lib that will contain the definitions for all the modules that we have in this project. Lib.cairo. And then which other one? ERC20. ERC20.cairo. And then I think re-entrancy guardian. Re-entrancy guard.cairo. Again, check on this thing. Maybe I can just go ahead and add, literally just push this thing to my repo. It's going to be a public repo so that you guys can work on it. Go to the terminal. Make sure there's a JIT folder, okay. Add everything. Dash all JIT init minus, this will be the init. And then I add the remote and I push origin main. Up. I think the remote is wrong. Yeah. Let me remove that remote, remove origin, and I will add it back. And then I push. It should work. Yes, awesome. So if you go back to the repo itself, I'll share the link to this repo. Let me just put it in the chat. This is what we'll be working from. I think the repo is public, so everyone should be able to have access to that code. Yeah, it's public. And then check back again on our installation. Awesome. Seems to be done. We go back to the code. And then look at the test. Try to run them. Some forge test. Wait for it to compile. And then maybe as it's compiling, we can also add a README. Allow me to close these empty files for now. No, that's the wrong folder. We can add a README to the root folder. README.md. And then we give it header. Cairo This is a simple AMM in Cairo, showcasing how to develop complex contracts by using and composing different components. Maybe I push that as that thing is compiling. Egypt. Yes, that's what I meant. Instead of giving me a suggestion, you should have just done the correction, but anyway. Commit, added the readme. By the way, if you feel I'm going too fast, please tell me. Again, this session is going to be a bit intensive, so I will need to go a bit fast. But if I'm moving too fast, please tell me so that I can explain myself a bit better. If not, let's continue, and then I push this to repo origin main. And when we look at the repo again, yeah, it should have the readme. Cool. So as we wait for the test contract, this one that came with the Scab from the Scab new project, as we wait for it to compile and run the test, maybe I can start filling out this code for the ERC20, the interfaces, the pair itself, the interface of the pair. This one I said I will not do. This will be the assignment. And then, of course, the reactivity card. Cool. So a quick question, by the way, before I move forward, PIN, or that I'm assuming that everyone here understands what an ERC20 token is, right? Or is that an unfair assumption? Again, like I said, this is a bit of a technical session, so I need to make sure that we are all on the same page. I'll assume everyone understands what that means. If you don't, an ERC20 basically is a standard in Ethereum that defines how tokens should be developed and how transfers, from one token to another should happen in the EVM, in the context of EVM. The EVM here being the Ethereum virtual machine, which is basically the thing that makes Ethereum Ethereum. Like without the EVM, Ethereum would just be another blockchain that produces blocks, more or less empty blocks and broadcasts, empty blocks that contain transactions for the native token without anything else. But because Ethereum aspires to be the world computer, it has the EVM. And the EVM is able to compute state, it is able to keep track of account balances, it is able to have tokens in it, and all these, the tokens now are what I'm referring to as the ERC20 tokens. And the whole point of this is to have a world computer that enables computation on a universal scale, so to speak. So we give this time to finish compiling and building. I can get started on the ERC to actually let me go to the Open Zeppelin ERC20 a component and actually just copy it, because I'll modify it a bit. so that we get rid of things that we don't need. Is this the one? Yeah, this is the one. Do that. And then go back to the code. Paste it there. Maybe reduce the size of that. And also the interface. Do the same thing for the interface. I see it has a dependency for its snip util, but we'll get rid of that very soon. Because what we need for the ERC right now is just the basic functionality for to and from the AMM, and that's about it. And maybe the approved functionality for testing, though I don't think testing is, I'm going to implement test in this session. I think that is for another session. The rest of this stuff, we can more or less stream it. If I check the terminal and again, get rid of the new one. This thing is still compiling. And again, no, it's taking forever, but anyway, we can still continue and I explain from. So now checking out the ERC20 components, you will see the basic features that I outlined before, which is number one. Any component that you are ever going to develop in Cairo and in Starknet, you should have these attributes. So from Open Zeppelin example, you can see that the ERC20 component, it has a Starknet component attribute. Without these attributes, the compiler cannot know that what this contract is doing or what this code is doing. It cannot know that this thing is a component. So this is very important. And if you scroll down, you will see that this component has its own storage. It has its own functions. But what I'm looking for is the public functions. Maybe let me close the terminal again. Close these things, one of these things for. Okay. Again, if you remember the slides, what we were talking about, the syntax deep dive. Yeah, I think I mentioned this, that whenever we need to have external logic in a component, let me present that. Whenever we need to have external logic in a component, it should be implemented in an IMPL block, and that block should be marked with this attribute, embeddable as, embeddable underscore as, and where, and you pass in the name, where the name is the name is the name that you'll be using in the contract to refer to the component. So if we come back to this code, we'll see Open Zeppelin exactly. They have defined the attribute, and this is the name that they have chosen for this block. And now this block contains all the public or the external functions that we can call from another contract, or from the contract that implements this component, as we will see when we get to the pair contract. And these ones are these functions are external and they're publicly accessible to the contract. Everything, basically everything under this ERC20 IMPL block is accessible to the contract. So it more or less meets our definition. You also see they have another block for metadata implementation. These again are external functions that will be accessible by the contract. When you can, contract will be able to call the function name of this component and get the name of the ERC20 token. You should be able to call the symbol, the decimals, etc. You can see we'll get rid of some of these because we'll not need all of them. It has the camel case only. It has a mixing implementation. So basically everything that we discussed about in the tutorial presentation, it's more or less done the same way. And then scrolling down, I'm looking for all these external functions. I'm now looking for the internal ones. Clearly, as you can see, it is denoted here. Everything now down below will be the internal functions. As you can see clearly, the embedded as name, where name again is the name of the component, that attribute is no longer added for these internal implementations. The internal implementations here, they're also functions, but you cannot now call them from the contract where you import, implementing this contract. For example, if I have this pair contract, I import this ERC20.Cairo component, I cannot call this function initializer, I cannot call this function mint, because these are internal functions to this component. They lack that, this block does not have that embedded as, attribute. And I think for internal functions, that's more or less it. So let me check again on the terminal. Check on Forge, still building. Wow, this thing is taking forever. Build a simple contract. Anyway, as that is doing that, I think we can clean out the this component so that we have only the things that we need. And in doing so, we should be able to now import it into the pair and work with it. So for starters, I think what I need to do is to, where is it? Yeah. I'm trying to think of a way to do this without making it confusing. Okay, for starters, let me get rid of all this, apart from the ERC20 implementation, I'll get rid of all these other blocks because I don't think we'll need them, and even the comments. Even the permit, we will not need permit for now. This will be a very, very simple AML. Even this Starknet IP metadata, we will not need that. So let me delete that. So now what we will have remaining is the total supply function, balance of, allowance, transfer from, and approve. Awesome. So this is what we'll be working with. And then for the internal ones, I think we can get rid of the hints and no, actually, let's keep the internal ones. And then on top of this, we need to, let me get rid of this comments. We'll also need to clean up the imports so that we don't have like this imports for SNIP 12 metadata, the dispatcher for IRS 6, we don't need of that. So I'll get rid of them. I wanted us to do that as I compile, but this thing is taking forever. Okay, let me switch for the sake of time, because I see we only have 30 minutes left. Let me switch to another project that I'd already developed and maybe explain there because this thing seems to be taking forever to compile. And I don't want to waste time compiling, and because we have some bit of code to cover. So just give me 1 minute, please, so that I switch to a better implementation and close this. And then I close the terminal. Open a new window. Instead of Cairo B2, yeah, and send the window here. It's legible. Okay, sorry, I'm doing this for the sake of time because I've realized in between the compilations and come on, why is this thing not behaving? Cool. This is what I developed initially, but because of time, and I've seen it's taking a bit longer than I expected to compile even the test contract, and we only have 30 minutes left or so, 30 minutes or 1. So I don't want to spend time, debugging compilation and whatnot. I want us to get into the meat of the code. So let me just use this old code that I developed earlier. I'll push this to the repo, and then you guys can take it. It will have the same functionality, more or less, what we've been discussing so far. But let me go into a deep dive again. Let me actually increase the font. Okay, cool. And you guys is telling me we have up to 50 minutes. Awesome. It doesn't hurt. Other than spending time debugging things that don't matter, let us just get into the meat of the bones of the contract. Yeah. That way, we actually learn something about components and composability instead of debugging. So, like I was explaining earlier, this component is going to have these modules. I'll not cover the factory module because this example, I don't think it's relevant. Though, if you're implementing a Ubisoft V2 style AMM, it is necessary. And only cover the ERC20 components, the actual implementation of the pair, of the contract itself, then the re-entry guard components, and of course modules. These ones are more or less self-explanatory. We have been developing contracts in Cairo. We should know how to define the different modules and how to import them and why this is necessary. I don't think I need to go into this. So awesome. Let us jump straight into the ERC20 Cairo component. Again, it has a trait for the internal functions, which are the initialize, the transfer, the approve. These traits basically define what to expect for the internal functions of this component. If I can take you down, where is it? Here. This is the implementation. And again, like I said before, this is the very key defining feature of components in Cairo. First of all, you will see that this component has the Starknet component attribute. For the external functions, you need to have this attribute always. Always remember that. This is key. You have the label as, and then the name. This is the name that you're going to be calling in the pair, as you'll see shortly. And then we have the external functions that we call from, these are the external functions that can be called from where we actually import or use this component. And on top of that, we have the internal functions that cannot be called from outside. Like you don't want to call the ERC20 initialize from outside. This would cause chaos. Imagine if you have a token that anyone can reinitialize anytime they want. That would cause chaos. So, and of course, we have the errors. Again, I think this is a bit self-explanatory. We have the events for the component, the transfer, the approval events, and then we have the storage. Storage for this component will contain the name of the token, the symbol of the token, the decimal of the token, the total supply, the balances. It uses a deprecated mapping, but that is fine for now. Don't worry about that. And then the allowances. And again, the traits for the internal functions. So that's basically it. This component now, we are going to import it into this pair component and reuse functionality that is in this component. So instead of, let's say you want to implement a token 7, instead of having to create a new token contract every time you want to create an MM, you can reuse some of this functionality. And this, when you reuse the functionality from the ERC20 component and the reentrancy one, you'll be able now to compose like a very concrete smart contract at the end of the day. With that being said, let me go through the reentrancy guard component. Same thing, it has the internal functions, the traits of the internal functions defined at the top. And then, like I said before, for every component, you need to have this attribute. It has the errors, and then this one does not have any external function, because this one will act like a modifier. If you're familiar to modifiers in Solidity, this one will be like this one will act like a modifier. So we don't have external functions. We'll just need to call this this component, and then initialize it in a unique way so that we can make use of these internal functions, the start, the log start, and the log end. And in doing so, we'll be able to prevent people from, when they're swapping, from calling the swap function again. Cool. So with that being said, let me talk about the interfaces now. These ones are pretty much straightforward. They will contain the interfaces. They contain the function signatures of the external functions. Again, you cannot have the signatures of internal functions of the components. So, for example, we do not have, you cannot define the signature of this internal function means in this interface. It should only contain the signatures of the external functions, like name, symbol, decimals, total supply, balance of. The reentrancy guard, as you've seen, it doesn't have any external functions. So of course we don't need, it only has 2 internal functions. So we don't need to have any interface. And then the pair, of course, if you want to reuse the logic of the pair somewhere else, this is a contract, this is not a component. But we have also defined the interface. Like if you want to write tests, this would be very, very, very important. Cool. So that being said, it's time. Let's get into the meat of the bones of the contract itself is a bit long. It's a bit. It has a lot of functionalities, like for adding liquidity, for banning liquidity, swapping, basically everything that you would think in the contract state, scheming, everything that you would find in a normal Uniswap V2 contract, this one, my implementation has it. But for now, we will only focus on the swap functionality. This one here. And before we even focus on the swap, again, let us start from the very top. You can see that when you compare these contracts to components, the starting attribute for a contract is always going to be Starknet contract. The starting attribute for component is always going to be Starknet component. That is the very key difference. And again, like I said in the tutorial, you're not able to deploy this component on its own. You're not able to deploy this component on its own, but you can deploy this contract on its own. And this contract can actually function the way it is. You can actually deploy it on the mainnet, deploy a few tokens to it, and actually have it run, as an AMM, a very simple AMM. But you cannot do the same thing with the components. So that is one very key difference between components and contracts in Cairo and in Starknet in general. Again, we have the usual imports for the call address, the contract address, getting the block timestamp. Some of these are used to calculate, to implement the Oracle implementation in USAB2. I'm not going to that. We also have the events for syncing, for mints, standard events that for swapping. These are the standard events that you find any swap to per contract. You have the entry guard event, EXC20 event, pretty much explanatory, the errors. Then you have the constructor for initializing this contract. This is the math used to calculate the reserves, the reserves after every sync. You have the internal implementation of the contract. It contains an update function. This one is called after swap. So you do a swap so that it can be able to update the new steps of the contract. And now, after the internal implementation block, you go to the external implementation. This is deprecated, but forget about it now. You should be able to initialize called the minimum liquidity. Someone is saying they can't see the screen. What screen? My screen, or is everyone able to see the? Maybe someone from Starknet Africa confirm this for me. Are you able to see the screen? Cool. Yeah. Okay. Yeah, so little bit more, maybe check on your internet. I think everyone else is able to see it. But I think, let me check on my settings. 1 second. Yeah, I think we're good to go. So again, I was sorry, to continue, I was explaining the external functions of the pair. These are the same functions that you'll find in any USAB2 pair. The initialized function, the minimum liquidity, the function to set the factory, the function to get token 0 in the pair, token 1 to get the reserves, and then the Oracle functions, price 0 cumulative, price 1 cumulative, and K last. The external function to mint, if you want to mint LP tokens, this is the function that is going to do that. And then another function to ban the LP tokens to get back liquidity from the pool. I'll be using the words pair and pool interchangeably, so please don't get confused. And then, of course, we have the actual function that we are going to look into deeply, which is a sub function. And then the sub function is where we implement the token cell, where you are able to transfer token to the AMM. And then the MF is able to transfer tokens out using these two functions. The token transfer, token 1, token 0 transfer, token 1 transfer. We'll talk about more about it. Skimming is basically being able to get funds out of the pool or the pair if they don't align with the reserves. And then sinking is sinking the reserves plus the balances of the tokens in the pool. Cool. So let us go, and then of course, where is it? There should be a test folder here, but it's fine. So for now, let us go through the swap function, because this is where you will actually see how these two components work together, the reentrancy and the ERC20 component. From the very get-go, you can see that we call the internal function lock start. And then we pass in the parameter of the reentrancy guard. If you go to the definition of this, where it is where did this thing go? Yes, if you go to the definition, this is a storage. We are actually referencing the storage. Anytime you see this attribute, you are referencing the storage in the component. And this variable will enable us to lock the swap, such that if I'm swapping from token A to token B, that swap should be locked such that I cannot, as the tokens are being transferred to my contract or to my wallet, I cannot call the swap function again and drain the reserves. So that is the purpose of this. Actually, let me write comments. That is the purpose of this first function call, lock the swap to prevent reserves or to prevent another call to swap as the swap is being executed. That is the function of this lock. From there, we get the contract address of the pair. We get the results of the pair. We read them from the storage, and then we make sure that the amounts 0 out, the amount 1 out that are being passed into this function, they're of course and 0. Again, standard Uniswap v3 checks, Uniswap v2 checks. Sorry, we get the address of token 0. We get the address of token 1, and then we assert that those two are not contract addresses. And then we assert the amount. If the amount out to transfer is greater than 0, we do. This is called an optimistic transfer. I'll explain why. Of token 0. And this is called an optimistic transfer of token 1 to user. By optimistic transfer, we mean that these tokens, even before the tokens that you want to sell, even before you put them back into the contract, this swap function is going to optimistically transfer this, and then do some at the end of the function to make sure that everything, the reserves balance out, and the x times y equals k condition has been met, so to speak. So this one, what you see in here, this is the optimistic transfer of token 0, token 1. And token 0 and token 1, by the way, are ERC20 tokens. And this transfer function is actually defined inside. If you look at the interface, this interface here is the ERC20. Is my mouse. This interface here is the ERC20 interface for the ERC20 component, which means that if we search for this function, this external function transfer, it should be found inside this. Not the event, but the function itself, not the internal function, but the actual yes. If we search for this external function transfer, this is actually this is a logic that's being called inside the token 0 transfer. Now imagine if you are implementing this AMN and you wanted to do this transfer, and you had to implement all this logic inside the contract. You see how cumbersome and how complex that would be. So for the sake of simplicity, for the sake of security even, because most of these components, like the open resolving components, have been audited thoroughly, it is better to do that component or to import that logic from a component that has been developed and thoroughly audited, and reuse that logic in the contract, like I've done here. So I'm reusing that transfer logic inside my pair contracts to optimistically transfer token 0 and token 1 out to the user when they do the swap. Then after that, I read the balance. Again, this balance is implemented inside this component, this balance of. It is this function here. It is not a function that like if I do a search of this, it is not a function that you'll see a lot of it, the calls, but it's not a function that I have actually implemented inside the pair contract. And that means that the logic that I'm using for to get the balance of the contract when I'm doing the swap, so yeah, when I'm doing the swap, the logic here is actually the logic that is contained in this function, this external function of ERC20. And then same thing for the balance of token 1. This function, the logic for this function is a logic that is inside the external function in this component. And then from there, we calculate, again, this is, I don't want to go into the math, but make sure that the variant in that equation, x times y, which is equals to k, make sure that the constant is always, when you're implementing, yes, come to Kazi. I see you've raised your hand. Go ahead and ask the question. Yeah.
Okay. Okay, so like I was thinking, since you're explaining these things, maybe you could run SN4 test so that the compilation will be running in the background, so that whenever you want to use it, maybe it might have been resolved.
Yeah. What I wanted initially was for us to implement this. Okay, what we will do is implement the test for this after I finish my explanation, so that we can go through everything line by line. Is that better?
Okay, no problem actually, but it was an update from what I noticed. So when you, after updating your Starknet Foundry, the first command, it usually compiles some binaries, but subsequently it won't take this time again.
I see what you mean. But that was for the initial, that was for the project that I wanted to demo with. This is actually, I don't think this one has any tests, which is good. That's why I'm saying we can implement the test.
All right.
Yeah. I have like 30 minutes, so we can implement the test for the swap. Is that fair?
Yes, sir, is okay.
Okay, cool. So, where was I? So I was explaining the actual functionality of the ALM. Here we just make sure everything from here going down, everything that I'm highlighting, and it might look a bit complex, but it is not. Apart from the immediate the event, everything here basically makes sure that these variants it's make sure that this variant it stays constant, because that is the whole point of this x times y equals k automated mathematical. Is by the time you're done with the swap, this k should always be constant or it should always be more, but it can never be less. If you multiply the reserves of x and reserves of y, where x and y are token 0 and token 1 respectively, they should be equal or greater to the constant k. They should never be less. So all that logic that you've seen there, starting from here, going down until the event is emitted, they make sure that that is what is happening. And as soon as you're done with the swap, of course, you miss the event that the swap, this to the sender of the swap, get the call address, the amount 0 in, amount 1 in, out, and the address that is receiving the tokens that you're swapping out. Then after that, again, you call the reentrancy guard and make sure that now you remove the lock. The reason for doing this is if the user wants to do another swap, at the end of this swap, they'll be able to do this. But they should not be able to do this at the begin at the middle. Sorry, not at the beginning, at the middle of this swap, because it puts a lot of chaos. Like it can lead to token hacks, it can lead to a lot of very bad scenarios. And that is more or less it. So Country Cousin has raised a very good question, a very good suggestions, which is testing. I think we can go ahead and do that, unless there are any questions. I know I've spoken a lot. Like I said, this, even the title itself says this is a bit advanced, it's a bit complex. It is not rocket science. Like you can ask me anything and I'll be able to, anything that is not clear, I'll be able to expound more on it. Any questions? Cool. If there are no questions, all right, you see the light. If there are no questions, I think let me set up the testing. And actually, before I can write the test, I think let me go to the documentation so that I can confirm everything that I've just been speaking for the last 1 hour or so. The official Starknet documentation, let me go there, and then we can come back and write the test. This is the official Cairo LAN documentation, or the Starknet documentation. It should more or less confirm what I've been saying. Let me increase the font. Goes into the definition of a component, TC for contract. It contains the variables, storage variables, as you saw with my components, the events, the external and internal functions. But then again, like I said very clearly, a component cannot be deployed on its own. And then it goes into the explanation of creating components. You first have to define a module that is decorated by this Starknet component attribute, very important. And then inside this module, you can declare storage tract, event, enum, all of that. And then the next step is to define the component interface. Again, you saw this with my ERC20 components. There's an interface here. Same thing. Yeah, sorry. With the ERC20 component, there's an interface there. And then you give it the trait of the Starknet interface. That bit is clear. Then the actual implementation of the component's external logic is done at the IMPL block marked with that attribute again. And this block will be the implementation of the trait defining the interface of the component. So again, going back to the ERC20 components, you can see the declaration here, that attribute, and then these functions here are basically the implementation of this interface. The ERC20 interface, the function names, symbol decimals are basically the logic that we have here, and they're calling, or more or less calling and writing to the storage of this component. Moving on, and then functions within this IPL block expect arguments like ref self and all of that. I'll not expand on this. You can do them yourself. And then gives you an example of the ownable component. This one is very clear. And then a closer look at the IPL. This is where I wanted us to get to. Then again, so this is what I was saying before. It's very crucial. The embeddable as attribute is used to mark the implementation as embeddable inside a contract. Basically, it means that without this attribute, there is no way of the compiler knowing that you intend to reuse the logic inside all these functions. The logic inside all these functions in another contract, if this is a component. So this is very important. You have to have this attribute decorating the implementation block for the compiler to know how to treat it. Going back to the documentation, it is used to mark the IMPL as embeddable inside a contract, and then it allows us to specify the name of the IMPL that will be used in the contract to refer to this component. In this case, the component will be referred to as ownable, and then it goes into much deeper explanation. And of course, if you want to, now this is the beauty of components. You can migrate contracts to be components. Why would you want to do that? Let's say you have a contract that has a lot of complex logic, and you feel that that logic can be reused elsewhere. That is why you'd want to, migrate a contract to a component. And you've got through the exact same steps that we mentioned above or mentioned before. The first step is to add the Starknet component attribute to the module, and then adding the embeddable as name attribute to the IMPL block that will be embedded in another contract, adding the generic parameters to the IMPL block, and then changing the type of self argument in the functions in the IMPL block to component state instead of a contract state. Oh yeah, by the way, sorry, maybe I should not skip that. When you look at the implementation of a contract, you will see that the state that is referred to here in a contract like the pair contract, let me go to the implementation, is usually the contract state. But in a component, you have to change that to the component state. Very important. And then the self here will refer to the component state and not the contract state. Moving forward, this is how you use components inside a contract. You declare it to the component micro, and then you specify the path to the component, the name of the variable, all of that. If we go back to the pair, you'll see this is how I'm importing or I'm embedding the ERC20 in the reentry guard components. I declare the path, the storage, and then the events in each component. Same thing for the reentrance guard, the path, the storage, and then the event. I use the component macro for that. as the docs specify, use the component macro, the path of the component, the name, and then the name of the variant in your component event. I'm referring to the component events. Cool. The rest of this stuff you can read. I now want to go to under the hood. This again gives you a much deeper understanding of the embeddable IMPLs. And then an IMPL is of a Starknet interface mapped with can be made embeddable. Embeddable IMPLs can be injected into any contract. And this, by the way, this injection into any contract, that is what we mean by composability. It is literally that simple. And by doing so, you add new entry point and modify the heading of the contract. If they give you an example there, then you have generic IMPLs. I'm not going to this because I don't think they're relevant. I'll jump straight to the contract integration. Cool. And then we've seen how the contract, this contract using IMPL alias to associate the contract generic IMPL within the contract. Okay. This you can read on your own. It's something I'm looking for. Is it the component dependencies? Oh yeah, sorry. Now testing the components is actually what I'm looking for. So because that is what you're going to get into next. Let's say you want to test this component, the ERC20 component and the reentrancy guard component. We want to make sure that they actually do what I say they're doing. You know, it is not something made up. How do we go about that? Like, how do we make sure that these two components work exactly as intended? Knowing that components in and of themselves cannot be deployed to, you know, like a DevNet network or to the mainnet or to a testnet. So how do you do that? Let's go back to the docs. Then, as you can see, as you can see from the docs, they say that testing components is a bit different than testing contracts. Contracts need to be tested against a specific state, which can be achieved by either deploying the contract in a test or by simply getting the contract state object and modifying it in the context of your text. But components are generic construct meant to be integrated in contracts that can't be deployed rather on their own, and they do not have a contract state object. So for that, if you want to test a component, basically, so this is how you do it. Let's say you developed this component called the counter component with this block and this external functions, get counter and increment, and of course this storage value. How do you go about testing this? Well, the easiest way to test a component is to integrate it with a mock contract. And then this mock contract will only be used for testing purposes. And it only integrates the components you want to test. This allows you to test the component in the context of the contract and to use a dispatcher to call the component entry points. And this is more or less what we will do. Though we will not need to have a mock contract. We already have a working contract. So we'll just implement tests for that working contract. But if you had, now this section is explained, if you had a component, or rather you develop a component, but you do not have a contract you're not embedded that component in a contract, this is how you would go about testing it. And then, yeah, you can see the test, everything that is needed in the tests. And then this is the other section I wanted us to get to. Let's say you don't want to deploy a mock contract. How would you go about testing components without deploying a contract? This is now reading the documentation. In the above section, we saw that components leverage generative defined storage and logic that can be embedded in multiple contracts. If a contract embeds a component, a has component thread is created in this contract, and the component methods are made available. We saw that through the use of the interfaces and the embeddable as IMPL block And then this informs us that if you provide a concrete contract state that implements that trade to the component state struct, you should be the component. Sorry, let me redo that. This informs us that if we can provide a concrete contract state object that implements the has component state, the component state struct, we should be able to directly invoke the methods of the component using the component state object without having to deploy a mock. And again, they go about showing you how to do this. Hopefully we have enough. Yeah, we do. We have enough time to write the test that we'll be able to do this. So here you can see that they want to test this component, the counter component, without deploying the mock contract. So what they're doing here is basically introducing a mock contract state, and then modifying the component state with that state, so that now they can be able to call the functions, the internal functions in that component. And I think that's more or less it. So the summary of that is that they define a mock contract that embeds the components they want to test, and then they define a concrete implementation of the component state using a type alias with a mock contract. And then after that, you can write the tests. Like you can see, if you write these tests, they will work as expected. And that's basically it. So this is what we are going to implement for the test. And before I go on the test, are there any questions so far? Because I feel, I know this thing is complex. It took me quite a while to wrap my head around it. I feel that from the silence, I might have, confused a few people, lost a few people. Are we together, or anything you feel I should expand more on? Okay, cool. Seems that we're good to go. So what to do, I need to set up my SCAP correctly. You can see it is still, they have my SCAP and VS code correctly. So give me a minute to do that, and then I'll share my screen again, and then we can continue the test. Is that fair? Cool. So I'll present for a minute, resolve my VS code issues, and then get back to writing the tests. As I do that, I think if there's no question for me, I'll ask one question. And then you guys can think about that as I fix my environment. Let me actually type it out here. So based on what I've talked about so far, how would you go about implementing the posable component? That is my question to everyone. Like, based on everything that I've just said for the last 1 hour or so, how would you go about implementing the plausible component? The floor is now open to everyone. It's my time to ask questions. How would you go about that? feel free to answer in the chat. Like, I think this will give me a clear, a clear gauge to know where we stand. Anyone, is there anyone open to this? How would you go about implementing the possible components and adding it to this AMM? No takers? Okay. Think about that, guys. I'll give you a few more minutes as I set up my VS Code to make sure that it behaves. Like, seriously, think about it. I'll give you 2 minutes and then I'll call out somebody to explain. So think about it. How do you go about implementing the possible component? Because literally this is going to be assignment after this. How do you go about implementing it in this? Think about that. Can I pick someone to answer the question? Haswini, do you want to? Because I gave you, I feel that this is something that maybe you've done. Do you want to maybe give it a go?
Oh, okay, yeah. Okay, so to implement the possible components, I think first things first is to check the Open Zeppelin Cairo smart contracts to find out where the possible component is, because the Open Zeppelin has different a structure for different components. Like for tokens, you can have the ERC20, ERC721. For access control, you have the enable and all of that. So when you're able to locate where the possible component is, then you can add Open Zeppelin to your smart contract dependency using your scarp.toml file. So once you add Open Zeppelin there, then inside the contract where you want to make use of the component, you can import the component using the Open Zeppelin part. So once you're able to import the component in your contract, then using the component macro, you can then set the part of the component. You also set the storage, which you've already defined in your storage struct. You also set the event, which you've also defined in your event enum. So once you do that, then you check the functions you want to interact with using the in the component. So you can just implement it from, so you put it inside an ABI embed v0 attribute so that it will be externally accessible. Then under that ABI embed v0 attribute, you can now attach the component to your contract. Then through your storage, the storage where you have already set the component, you can access any of the external externally made functions from the component and all. So I think that is a high level way I'll go about it. But writing the code will be more will give more details to it.
Awesome. No, actually, that is the answer I was looking for. Like, I wanted to, make sure that you understand the flow from how you go, from Open Zeppelin to actually having the functions to call inside your control. So, yeah, you've done a good job. Congratulations on that. But you're not you, Kasini, but I think I'll call someone else. You guys are not off the hook yet. So that's how you implement the posable component. This one is quite easy. The next question, actually, let me type it out so that I make sure we're on the same page. So after you import the posable component from OZ, how would you embed it? I think Aswini has touched on this a bit, but I want to make sure that people understand this concept, because this is key to this whole tutorial. How you embed components into contracts. How would you go about embedding that? How would you embed this component into the pair contracts? And what function would you call? And by the way, feel free to do a Google search to, check a few sources here and there, ask ChatGPT, whatever, so that you at least and make sure that at least we are all on the same page. So again, going back to this, what function would you call to pause the swapping? Again, this is going to be your assignment, so it's better I make sure that we're all on the same page. Think about that for a minute, and then I'll think and call somebody else to answer that question. So basically, some of the things I say, how would you embed this component to the pair contract, and what function would you call to pause the swapping? Think about it. Can I call someone? Stephanie, do you want to give it a try? Okay, Kevin.
Good evening, Mulili.
Good evening, Kevin. Yeah.
I think that one is more complex, and I'm new in this language. Maybe I can digest. And
But that complexity, those are the questions I need you guys to ask me, and people are quiet.
no, we'll ask later after the class.
Okay.
Yeah. Be frank,
Uh-huh. Okay, cool. Country cousin, my bro. You want to give it a try? I don't think CC is with us. JN Kamal. I'll keep calling you guys until somebody, rises up to the occasion. Like, seriously, think about what you've talked about for the last 1 hour. How would I've gone through this thoroughly. How would you embed this component into the pair contract? JN Kamal. Okay, since it's not with us. Moses Tosin. Okay, my last I'm going to ask is choice. You want to give it a try? Noted, Moses. We'll get the recording later. Isaac. Yes, please, Isaac. Go ahead.
So like I wasn't really able to like really flow, but I'll just say like what I think can work in this situation. So just like Kesuni said, like when he answered his, I would embed this component into the pair contract, using the same ABI embed v0, should I say it's a hook or a call, whatever, like to like basically make it external function the same, so it can be like accessible outside that context. Then to post the swapping, I would be defining like a function that basically calls a pause option from the possible component itself to like pause the
Okay.
swap. So like this is why I think I'm not really sure if it's like streamlines very well or works
No,
well.
no, no. No, that works. I mean, your explanation is very concise. But the answer I was looking for is, first of all, you would need to call the component macro. I think I should just show that in the documentation. And then, specify the path, the storage, and the events in that component, basically that macro. And then from there, now you can go ahead and do the rest of the things that you started on. So Isaac is correct, by the way, so that Isaac is not wrong. But this is the first step. You cannot reuse a component in contracts, or rather, you cannot reuse components, because in this case we have two components that we are using. You cannot reuse components in a contract without first having, to specify the component macro. This is super important. Without this, there is no component composability or reusing that you're doing. Okay. 4. So I think from basically the gist that I've gotten so far is that I know this advanced this advanced logic about components and composability is a bit complex. It also took me some bit of time to understand. And my environment, for some reason today, has decided to misbehave. Like SCAB is not working at all. So I think what I'll do is that because I think everyone has access to the link of the repo, right? I shared. Let me just reshare it again. I'll push all the codes to that repo plus the test by tomorrow morning, so that I have some bit of time to clean up my environment. I don't know what happened. Might have done some silly updates. And then from there, of course, I'll share the slides in the Telegram chat. I'll share, you'll have the recording. From there, you guys can clone this repo, do the assignment of implementing the possible components. And then, as you do the assignment, once you're done, from the fork of the repo, you can do a PR main. Then I'll be able to go through the code and actually, help out where things are not flowing. The whole point of this exercise, I think even Paul mentioned, what goes it's not to bog people down. It's actually to help us all learn Cairo better. So don't feel bad. I'm not trying to make people feel bad or feel dumb, so to speak, for not understanding some of these concepts. No, the whole point of this is to help us all learn together so that we can be able to become the best Starknet and Cairo programmers they can be. So don't feel shy in asking questions. Don't feel shy in, when you make mistakes, don't suffer alone. Like, we're here to help each other. So yeah, I'll push the code to that repo. Then you guys can be able to, I'll push it by tomorrow morning. You guys can be able to fork, implement that possible components, and then do a PR to the original fork, to my repo. And then from there, I can be able to now come in and assist. From the PR you guys make, I can be able to come in and assist everyone individually. My goal is, in the next few days, even before the next week starts, everyone has a very clear understanding of components and composability in Cairo. That would make me very happy. Okay. And I think, yeah, for now, that is the end of my session, unless there are any more questions or any more remarks from Starknet Africa.
Yeah, thank you so much. And I believe, you did justice to your session, right? I mean, even though Scab misbehaved a little bit though, but yeah, the assignment, please, we'll share it tomorrow to everyone, right? So
yes,
always make sure you complete your assignment from week 1 to the current week. So it would help us confirm, also follow up with people that are active in the bootcamp, right? So next week we'll have Mr. Kaswini teach testing in Starknet, right? So I guess Mulili wanted to touch it today, but yeah, that's basically the topic for next week, right? So we urge you to also be here next week while we dive deeper and all. So I noticed maybe the energy has reduced a bit, but we just have 2 more sessions to go, right? Just 2 more sessions. But I'm actually thinking maybe we could do a bonus session whereby each tutor comes up to tackle it's a bit of the assignment. I mean, I don't know if that's cool. I mean, what do you guys think? If you think it's a cool idea, just give me a thumbs up.
Yeah, that's an excellent idea. I love it.
Yeah, so we will come up with details and set up a bonus session for that and share with you guys as well. But regardless, everyone has been doing great, and we are looking forward to having you as active Starknet developer and also an active member in the Starknet Africa ecosystem, right? So, but yeah, regardless, if there's nothing more to talk about, I guess that would be it for today. And good night, everyone. And thank you, Mulili, for the amazing session.
No worries. Good night, guys. Let's continue.